So what if one of the most popular ways to build with AI is actually holding you back? Today, we're diving into a pretty bold claim from Chroma's Jeff Huber that it's time to get past all the hype around RAG. Let's really break down what that means. Okay, wow. Let's just start there. That is a very strong statement, especially coming from a leader in the vector database world. It really makes you think, if the super popular RAG framework is out, what's in? And, more importantly, why the big change? To get why this shift is happening, you first have to understand the biggest problem that developers face when they're trying to build production-ready AI today. It's a challenge pretty much everyone in this space is feeling. Jeff Huber has this brilliant way of putting it. He says the gap between a cool demo and a reliable system you can actually ship, it's the difference between alchemy and engineering. Alchemy is just messy and unpredictable. It's like stirring a pot and just hoping for the best. Engineering, though, that's disciplined, it's systematic, and most importantly, it's reliable. So the whole just add more data approach, which, let's be honest, is what a lot of people mean when they say RAG, that feels a lot like alchemy. It's really time we got a more structured, more engineered way of building these AI apps. And this simplistic, kind of messy approach, well, it has a name. And it's basically the villain of our story today: context rot. I mean, you'd think more data is always better, right? Just give the model every piece of information it could possibly need. But here's where it gets really interesting. Research from Chroma shows that the exact opposite is often true. And this chart just visualizes the problem perfectly. It's totally counterintuitive, but as you cram more and more information into that LLM's context window, its performance actually gets worse. The model starts to lose focus, it ignores instructions, and its ability to reason just degrades. And that is context rot. It's the core reason why just throwing a ton of documents at an LLM is a flawed strategy. It just won't scale if you're trying to build reliable, production-grade AI systems. So if the problem is just stuffing the context window full of, well, junk, then the solution has to be a much more deliberate approach. And this brings us to a whole new discipline called context engineering. Now, this isn't just another buzzword. It really represents a fundamental shift in how developers need to think. It's all about quality over quantity, about carefully crafting the perfect, concise set of information for the model to work with at any given moment. And this, right here, is the key takeaway for anyone building an AI today. The most successful companies, they aren't just masters of models. They are masters of context. That's the real competitive edge. Okay, so this all sounds great in theory, but how do you actually do it? What does this really look like in practice? Well, here's the playbook. So the playbook has 5 core principles. First up, you've got to be precise. Talk about retrieval and re-ranking, not just this vague RAG term. A key tactic is to use hybrid recall. That's just using both keyword and semantic search to get a wide set of initial candidates. But the most important step is to then re-rank those results to find the absolute best ones before you ever build the context. This is how you fight context rot. This whole process starts with how you prepare your data. You don't just dump raw text. First, you parse and chunk it, breaking down your documents while keeping their structure, like headings and tables. Then you enrich this data with useful metadata, summaries, keywords, you name it. Only then do you embed it for search and write it to your database. It's all about building quality in from the very start. Okay, so then, when a user asks a question, the whole thing works like a funnel. First is recall. You grab a broad set of maybe 100 to 300 potential documents. Now here comes the magic step, re-rank. You use a smaller, specialized model to score that whole initial set for relevance, and you narrow it down to the top 20 or so. And only then do you get to context assembly, where you build that tight, clean prompt for the main LLM. You're filtering for quality, not just piling on quantity. And finally, great systems learn, right? They don't just stand still. That's what the outer loop is for. You create what's called a gold set, basically a collection of perfect question and answer pairs, and you're constantly benchmarking your system against it. When you find mistakes, you do error analysis to figure out why. All of this feeds into the system's memory, letting it improve itself over time. And this leads us to the ultimate payoff of great context engineering, creating AI systems that have a robust, useful, and persistent memory. I mean, just think about that for a second. A system that can learn from its interactions, that can remember user preferences, and that actually gets better over time. That's the real goal here. And context engineering is the practical, disciplined way to get there. And believe me, this field is evolving fast. Soon we're going to see continual retrieval, where models fetch new information multiple times while they're thinking. We might even see systems staying in latent space, which means they'd skip natural language altogether and pass compressed data directly between models. That would make them incredibly fast and efficient. You know, that final question, what if AI could think directly in data? That's really where all of this is headed. And getting there means we have to move beyond the simple hype of RAG and embrace the discipline of context engineering. It's the fundamental difference between hoping for a magical result and having the engineering discipline to actually create one.